For coming to this talk by Dr. Juan Gilbert. This talk is brought to you by the ACM Distinguished Speakers Program, as well as the HCI program here at Iowa State. And Dr. Juan Gilbert is chair of the Human-Centered Computing Division at Clemson, and also professor in automotive engineering out there at Clemson in South Carolina. They have BMW to help them out, like John Deere helps us out. Mm-hmm. And he has done research projects in spoken language, advanced learning technologies, usability and accessibility, culturally relevant computing, databases and data mining, has been named a fellow of the American Association of Advancement of Science, and is an ACM Distinguished Scientist, one of the 50 most important African Americans in technology. He's won numerous awards, published many papers, given many talks, and recently testified before Congress on electronic voting, on which he's going to speak to us today.
All right. Thank you.
No relationship.
All right, so I'm going to talk about voting, which is interesting being here in Iowa. There's a relevancy there, as you'll see. But I'll begin with where it began in 2000. Presidential election. So some of you probably remember the issue that occurred in Florida, where you had recounts, allegations of voter intimidation, but more so you had this, the butterfly ballot, which proved to be problematic in many ways. The biggest issue with the butterfly ballot is, as you can see here, for individuals that wanted to vote for Al Gore, he's listed second on the ballot on the left. However, his punch hole is actually the third one. So if I wanted to vote for Al Gore, you can see where, let me pull him out. You can see where he's here second, but the second hole is for Pat Buchanan. That caused some issues. With the butterfly ballot, the process is a punch card where you take a pen and you punch through having what's called a Chad drop. And that was how you would designate your intent. Well, we had this happening, hanging Chads. And people often ask, well, what does this mean? If the Chad is hanging, is that a vote or not? Well, the appropriate answer is, it depends on if it was for my guy or gal or not. If it's for the person I like, then this is a vote. If it's not, then I don't think so. But the hanging Chad, as controversial as it may seem, was not as controversial as the pregnant Chad. So you look at this and you say, well, what does that mean? Did they vote or not? And why would anybody do this? Well, the reason this occurred, this is actually an engineering problem, where you had the ballot put into a plate. When you punch the Chad falls down into a bucket or a plate. If you don't empty that, what happens? They stack up to a point where you punch through and you're punching on Chads and you can't break through and you end up with pregnant Chads. So as a result of that, what happened? This. You look at this guy and you say, well, how can you possibly have any confidence that he can accurately count anything under these circumstances? It's just not going to happen. Well, as a result of that, the voter's intent was not accurately captured. And after the voter left the polling place, the intent was lost. So what did we do? We said, let's modernize voting and move towards more electronic means, these direct recording equipment, DREs, or optical scan machines. Well, DREs made their way in and just as quickly are making their way out. The problem with the DRE was that it's a touch screen and you had issues of security. So essentially, the idea of voting on with a touch screen or a computer is very simple to implement. Meaning Computer Science 101, you could have people create a voting machine or a voting interface. The problem is that doesn't mean it's going to be good. And that's what happened here. People were able to hack into these. You had lack of recount and auditing capabilities. And then the biggest issue was ballot design. And I'll show that to you in a second. Professors hacked into the machines and went on TV and did it in less than a minute. That didn't help at all. Proprietary software issues. We had instances, for example, in New Jersey, where the machines were going to be scrutinized or reviewed, and the actual manufacturer said, no one can look at them, it's proprietary, and if you do, we'll end up in court. And they threatened to sue a particular faculty member over that. We had elderly and disabled voters had a difficult time with these interfaces. There were allegations of touchscreen issues such as vote flipping, and I'll talk about that in a second. And then in 2002, as a result of this, we had the Help America Vote Act, which required all citizens to be able to vote or get equal access to voting. Essentially what that meant was each precinct was required to have an accessible voting machine. That created another area of issues in that you had another machine introduced and was used infrequently, so poll workers didn't know how to set it up. They forgot how to use it, and as a result of that, a disabled person or a blind person shows up and says, I need to use the accessible voting machine. They said, it's over there. I don't know how to use it. Those things happen. So they said, well, come on, I'll vote for you. All those kind of things happen. Then in 2006, just to point out the issue with ballot design, there was the issue in Sarasota County, Florida. You had 18,000 undervotes, which is 15% of the voters, where typically, and in the state at the same time, was 2%. So Buchanan won this contest where the undervotes occurred by 369 votes over Jennings. You had 18,000 undervotes. The margin of victory is 369. So people said, aha, we know the problem. Somebody hacked the machine, and that's how it happened. They did, put the machines out, tested them. They could not find any evidence of the machines being hacked. So the thought was that Buchanan honestly won over Jennings, and because they couldn't determine that it was hacked. But there was an issue. So I'm assuming we have some HCI people here. What's the issue? Anybody see the issue? This is the screen. Does anybody see Buchanan? Probably after I told you. This is what happened. This is what the paper looked like. They actually translated the paper directly to the screen. And what they discovered was that those people, a minority, but still a significant minority, never looked below this line. The way this is organized and appeared on the screen, the attention was drawn to state here. They thought this was the top of the screen. They never even saw the contest up top. That's a design issue. More than one contest on the screen, translating paper directly to the screen, and you end up with 18,000 undervotes with a margin of victory of 369. This is a good example of how ballot design influenced an election, results of an election. Here's another example. You had 3 contests on a screen. Some of the calibration issues. If a person was to touch Harriet Tubman and Frank Robinson at the same time, the screen would average those and select Sammy Davis Jr. We saw an issue where, and I talked about vote flipping. In West Virginia, there were allegations that people were trying to vote for Barack Obama, and it was flipping their vote to John McCain. That screen, we actually did a YouTube video in response to explain why that happened. People thought, again, the system was being hacked. Well, the rules were that the incumbent's party would be on top and then the challenger underneath. So McCain's the Republican, so McCain was on top. So let's look at Adams and Franklin. So imagine that was McCain and this is Obama. And what we discovered was that, we did a research study on this and we're in the process of trying to publish those results, was that approximately 6% of people, when given an interface with a button, name, and a checkbox, 6% will touch the name. So when they were trying to vote for Barack Obama, or in this case, Ben Franklin, they would take their finger and touch the name, but they were inadvertently touching the bottom of McCain's button. You see? So on the screen, they were going for the name and hitting the bottom of the button on top, and they said, it flipped my vote. So as a result of this, we did a study, and we were able to show 6% of people do that, and the margin of victory can be within that 6%. So those are just a couple things. We saw things where people would double tap. And if your screen is very responsive, that causes an issue. So if I double tap, what that means is that I made a selection and then it would change the screen and the tap would register before the next screen was shown. And you go to the third screen and you never saw the second screen. Things like that. So as a result of those, people said, let's move to optical scan. Well, optical scan was thought to be a very easy thing to use because they said, if you go to school, everyone's done Scantron or optical scan. This is the way to do it. Well, there were issues with optical scan. Remember, ballot design is what caused this, the butterfly ballot and the pregnant Chaz. So let's look at 2008, the Minnesota Senate race, Coleman and Franken. You had 2.4 million votes cast. The margin of victory was 312 votes. It took 239 days after the election to reach a decision, and $11 million were spent on attorneys. Now, if you're an attorney, you like this. This was good, right? They made a lot of money. However, this is an issue, and it was not reported as the same when we saw issues with voting machines, meaning the DREs were reported in the media, whereas this was not. So let's talk about what the issues were. So here's a ballot from that contest. Who did this person vote for? You say Norm Coleman? But when this was scanned into the machine, what do you think the machine said? Nobody. This is an undervote. Neither one was selected. The machine would not have counted this. But a human being looked at this and said Norm Coleman. That's the difference between the machine and the human counter. What about this one? Who is this one for? Al Franken. The machine may or may not pick that up. But this was a little more clear. And so when I show this ballot, people say, well, why would anybody do that? Well, what we discovered was that there were a number of individuals, in a lot of cases seniors, who had a shake in their hand and couldn't accurately do the oval. So they ended up with things like this. What about this one? Well, clearly, if I'm from Norm Coleman, this is his vote. But if I want Al Franken, I'm arguing for him. So what actually happened is most likely this ballot was thrown out. Neither one. If you think that's bad, what about this? So what do you do with this? I have no idea. So again, these are real ballots. And the voter's intent was not accurately captured here. With a margin of victory that small and you're throwing out more ballots than the margin of victory, that's a problem. So optical scan had a catastrophic failure in this case and wasn't widely reported. Another optical scan blunder was more recent in 2010. Alaska Senate race. Lisa Murkowski, some of you probably will remember this, it wasn't that long ago. Joe Miller and Scott Adams. So Joe Miller and Scott Adams were on the ballot, and Lisa Murkowski had to be a write-in. So 98% of the write-ins went to Murkowski, allegedly. We'll see. Which is 1.44% successfully challenged by Miller. So Miller said, no way, I'm going to challenge that. The write-ins couldn't have won. So the issue was, how do you spell Murkowski? So what happens? Here we go again. Looks familiar, right? Look at this one. Is this a vote for Lisa Murkowski or not? What about this one? Markowski. There's one. They didn't fill in the oval on this one. Lisa M. I'm sure that was challenged. Just Murkowski. I think they were voting for her dad, not her. Oh, they didn't spell that one right. Who knows? They wrote below the line. Will they count that against them? And then, of course, that's not technically her name. And then there's always the favorite Mickey Mouse. And then there's the person who's angry at everybody. None of the above. Take our country back. So, Optical Scan has some severe issues, and these were exposed. So as a result of this, and other examples, I could go on and on about these, we did research, and we've created what's called Prime 3, the premier third-generation voting technology. First generation is paper and pencil. Second generation would be touch screens and things. And then third generations are these multimodal devices, which I'm going to show Prime 3. So Prime 3 begins with just a blank piece of paper. It could be a specific stock. It could have a watermark, but it's blank. This occurs after the voter is authorized to vote and using the voter registration database. So after they say you are who you say you are and you can vote, a single piece of paper is put into the voting machine. It's the only one. It's blank. And then you vote. Let's talk about the interface. It's multimodal, as I mentioned, and voters can vote using their voice or sound and touch interchangeably. On the visual side, you have a large touch screen with fonts. There's a debate about images or no images. So from an accessibility perspective, having a person's picture on there would be very helpful. However, there's issues with that on the other side that says we don't want to put a person's face there. We don't get into that argument. We have touchable names, and you'll see what it looks like in a second when I do a demo. The voter touches the screen, they get a confirmation that's visual, and there's only one race per screen, and the voter confirms the ballot twice before it's recorded. On a haptic side, we have a rocker switch, and this is what the switch looks like. So on the right side, you touch that, and it will actually send the system to the next prompt. And if you're on the left side, you touch that, and you can feel it has a texture. It will actually make a selection. So I could put on a headset, and it would actually be talking to me, and I can navigate with this switch if I was blind or something like that. On the verbal side, there's a headset by which the system is speaking to you. So it prompts you, you hear it in the headset, it's not out loud or anything like that. And we've done this with pre-recorded speech or computer-generated speech. And what we found was that it was very interesting. We did pre-recorded speech, meaning we had a person actually say the prompts. And it was interesting. We discovered that that was not a good approach. So I'll explain to you in a second why that is. So people, when we use text-to-speech or computer-generated speech, people clearly know it's a computer, and they don't like the voice, but they can understand it. They don't have a problem understanding it. But when we put a real human voice on there were a set of people who said, I'm not using this. Somebody's talking to me. They're going to know my vote. I'm not making this up. So we had to use a computer-generated voice because if you put a voice that's too lively on there, you have certain people who get suspicious by that. Now, remember what we're doing. We're designing a voting technology. So for those of you in HCI, you often talk about user-centered design and your target audience. Well, the target audience here is like everybody. I mean, it's all over the place. So you have to be accommodating of a very diverse group. So how do I respond? The voter speaks back, but you don't say who you're voting for. You wouldn't say Barack Obama. You say words like vote or continue, or you can simply blow into the microphone and make a selection. Okay, so with this technology, what we've been able to show is that people that have all these different abilities or disabilities all can vote privately and independently on the same machine as anyone else. So if you can't see, if you can't hear, if you can't read, if you don't have arms, you can vote on the same machine as anyone else privately and independently, which eliminates some of the problems we talked about earlier with training with poll workers. So whenever you do voting, as I mentioned earlier, there's questions about security. So let's talk a little bit about security. Prime 3 has no network access. There's no direct keyboard. It's just a touch screen. We designed it so that it ran off a bootable DVD. So the idea is that you have this DVD that you put into the machine, you turn it on, and it runs. And in other words, this creates an environment where we can create what we call a stateless machine. The machine, we can take the hard drive out of it. So if there's a virus or some way to attack this, it has to be on the machine, on the DVD, meaning it can be detected, because there were allegations that on the DRE machines, I could put a virus in it, and after the election, it can erase itself and no one would ever know. That wouldn't happen in this particular case. Now, you could try and attack the BIOS and do some other things, which we've investigated, and those don't work out very well either, and I'll explain that why in a second. What we do is we print the ballot on demand. The voter verified ballot is printed. So remember that single sheet of paper after you vote? It prints your options. And we refer to this as a green approach to voting, meaning we don't throw away paper. If you do, you can just recycle it. In other words, if I vote and I'm not happy, I can spoil the ballot and they stick another piece in there and I vote again. What does the ballot look like? Here's an example. So in this case, our ballot has no ambiguity. So we saw the issues of voter intent not accurately being represented, like an optical scan. That won't happen here. You see Bugs Bunny, President, Daffy Duck. There is no ambiguity. And this ballot is then put into another machine where it is actually scanned using optical character recognition. So, and we're actually going to do a study on this where we believe, our hypothesis is that the margin of error between a human counting and the actual OCR machine counting is going to be significantly reduced because the machine, in this case, actually has to read the entry and then tally it like a person would. Whereas an optical scan is looking for marks in a specific place. So you can have a greater margin of error with optical scan than you would here. Well, remember, the blank piece of paper is put in the machine, and then I vote, and I say I'm done, and then it prints this. So this is my ballot. And then this goes into the scanner, which uses the optical character recognition to tally, and then the ballot is put in the ballot box. And then we recommend a manual statistical audit of those paper ballots to confirm that the actual tally machine is correct. And this is just some data about statistical audits, showing the statistical power of 10% audits. And people have done a lot of research on these audit techniques as far as counting ballots. And we'll talk about that in a second as well. Yes? the question is, how can I guarantee the accuracy of a write-in candidate on the system? I actually, to show you how big a problem that is, I had a student just do her dissertation on that very topic. So we call it anonymous write-in. So we have different methods. So one example, the way they currently work, and I'll do a demo in a second, but let me talk about that. The way current machines work, you have the alphabet. And so you need to spell a person's name. So you can hit a switch and go all the way A, B, C, D, all the way over, and then keep going. So for your math types, that's a problem, right? So that's on the order of n over 2 on average, because you got to go at least halfway through the list every time to find a letter. So what we did was we took the alphabet and put it in 5 groups, and then we did a statistical analysis of potential names that could be written in. And so what we do, we would present you with, you're going to spell the person's name. Say the last name. Does the person's name begin with an A, B, C, D, or E? And say vote. If you say yes, then it says, is it an A, is it a B, or C? And then you say a C or whatever, and then we can make a guess at it. So you know how you type on your phone or something and it's looking ahead, predictive spelling? We can do some of those things. And so we're able to speed up and increase the accuracy, and then it reads back the name to you as well. So we are able to do that kind of thing, and we did a study on that, showing that was actually significantly faster than traversing the alphabet linearly. Okay, so let me pull up prime 3. Whoa, that wasn't bad. Okay. So what I can do is I'm going to run prime 3. So prime 3, I'll give you a couple of points up front, and then we can discuss it afterwards. It was written in Java. It's 100% Java, and this is the first version of prime 3. So I'm going to go through it and vote, but I won't completely vote because I don't have a printer hooked up, and it would try and print. Actually, I could. I don't know if I have printing on. Let me see here. I could turn it off. So I have a file. Print ballot. Oh, yeah, I'm going to turn it off. I don't have a printer on here. Okay. So let's start it.
Welcome to Prime 3. There is one option to select from. To start voting, say vote. To start voting, say vote.
Vote.
Selected. Start.
Now I would have a headset in the microphone.
You are voting for the voice speed.
So I could touch it or
Welcome
speak to
to Prime
it.
3. You are
Our
selected.
blind voters usually listen to it this way.
Welcome to Prime 3. You are selecting the speed of the voice. The current speed of the voice is very fast. There are 4 other voice speeds and another option to...
But I can't listen to it that way.
Welcome to Prime 3. You are...
So I'm going to click through.
You are voting for president. This is one of 4 ballots. For president, no selection. There are 5 options. You can select only one candidate to vote for Mickey Mouse, say vote. To vote for Bugs Bunny, say vote.
I don't know where my microphone is.
To vote for Optimus Prime, say vote.
Vote.
Selected.
Usually I can just
Optimus
blow
Prime.
into it, but I would have a headset on. So
You are
got
voting
Optimus
for president.
Prime. I can click through.
You are voting for vice
I
president.
can write in here. If I wanted to, I'm going to go back. You would not see the finger.
You are
I don't have
voting
a
for
touch
vice
screen. That's why the
president.
mouse is there.
This is 2.
So let me click through.
You are voting for... You are voting for... You are voting for Proposition 1. For... You are voting for
Always say
Proposition
yes
1.
on this one.
For Proposition 1, yes was selected.
Okay. So
You are not done voting.
this is my
you must verify your
review
ballot
screen.
before it is cast.
I can go back
This is
and
your
change
first
them.
verification thereof.
And then I'm still not done.
You are not done
I can
voting.
go back.
This is
or I
your
can
last and
cast my
final
ballot.
chance. Thank you. Your ballot has been cast.
And then it would print my
Goodbye.
ballot, and it would look like the thing you saw. So let me walk you through this, and I can run it again if people want, because it went pretty fast. But let me walk you through some of the things you saw. Notice that whenever I made a selection, the screen would gray out. That was done deliberately because of dragging of fingers and double tapping. The prompts there were designed with blind voters in mind. The development team, interesting enough, would test it like what I was doing, looking at it, and we tested with blind voters, and they said, this is horrible. So I had to tell them to test it and make them do it this way, with their back to it so they couldn't see it. So it was just a bunch of things that went into the design. Let me talk about some findings. I want to get through some of these because I have some new stuff I want to talk about. We did a ballot counting study with seniors comparing what's called the VVPAT, which is if you go to the store and you get a receipt when you buy something, the thermal printer, that's a VVPAT, meaning that you vote on the machine, it just prints on that continuous roll your ballot. Optical scan, and then the Prime 3 ballot. And we did studies in these groups, and it was in conjunction with Rice University and Auburn. And this was the original ballot we started with, which, don't go crazy, it has some design issues. And this is not, as you can see, we upgraded from this to the ballot we have now. This was the ballot we used in optical scan that they were counting. And I just want to get through a couple of these. Auditing time by ballot type and order. So they counted 2 contests, the first race and second race. As you can see here, the time for optical scan was faster than the others. The candidate error proportions, meaning when they counted a contest, how many errors occurred, optical scan overall had a greater error proportion than, for example, Prime 3. The ballot total error proportions by method. So read and mark was a team of 4 people. One person reads the ballot selection. Another person looks at it and confirms it. And the other 2 mark for the person they called. Sort and stack is you read it and put it in a stack and then count the stacks. So read and mark was definitely superior to sort and stack on every measure, actually. Look at the candidate errors. Read and mark was much lower than sort and stack. Auditing time by these. Read and mark was down. So read and mark destroyed sort and stack. And if you look by these SUS, you guys know what SUS scores are, right? System usability scores. If you look here, Prime 3 had a higher satisfaction amongst people for counting and read and mark. I don't even look over here because that was horrible, sort of stack. So with this, we did redesign the ballot, as you saw. We also ran studies on anomaly detection. So studies where ballot anomalies were deliberate in intent. So 108 participants, and this was a study done at Rice that we replicated, meaning they voted on a voting machine, and at the end, on the summary screen, the machine flipped either 1, 2, or 8 of their selections. And they wanted to see if people noticed. And in their studies, the results were horrible, meaning when 8 were flipped, only 39% noticed, 2, 37, and 1, 24% noticed. Overall, they discarded 9%, but you can see here 45% did not notice overall. And these are just not good numbers. If it's flipping your vote, people didn't notice. So there were other studies where 66% didn't notice. So we saw these studies and said, well, we're going to do one. So we ran the same study. We had 110 participants. We did the 1, 2, 8 flips, and we had these results. If 8 were flipped, 100% of people noticed, and we never told them to look. The experiment was set up that we want you to vote, and We want to see, they thought that we were testing the usability of it and not looking for anomaly detection. And so the study would go and they say, wait a minute, that's not who I voted for. We said, thank you, study's over. That's how the study went. So you can see here where 78% of the people noticed if it was a single anomaly. Overall, with the paper, 17% noticed on paper, 10% didn't notice at all, and we had 73% notice on the screen. So again, with Prime 3, we designed it such that if there's vote flipping occurring, people would notice at some juncture. We did studies at Auburn University with 200 students. We did studies with the Osher Lifelong Learning Institute, which is a group of seniors. I talked about the audit study. We went to the Alabama Institute for the Deaf and Blind 3 years in a row and did studies there. We just completed the vote flipping study, which we're in the process of publishing that. We did elections for the National Society of Black Engineers, which is the largest student-run organization in the world. So the last 4 years, they've used Prime 3. We did an election for the National Council on Independent Living, a group of people with various disabilities. We did a mock election in 2008 at Auburn University, and we're working on some potential local elections. Here's a picture from the mock election. So as you can see here, we put the monitors facing the wall. We had the computers there, the touchscreen, headset with sanitary covers, and we set it up so people could vote that way. Conclusions. In 2007, Professor Michael Shamos at Carnegie Mellon testified before Congress on the Ballot Integrity Act. And when he testified, whenever you testify before Congress, you submit your comments first. But I talked to him the night before about Prime 3, and he deviated from his comments and talked about it in Congress. And so they spent 2 to 3 minutes talking about our technology. Dan Rather came when I was at Auburn. He interviewed us, did a good story. We went to Capitol Hill, and you can see Congressman Ellers there using Prime 3. Then in 2008, I went and testified before Congress about our technology and talking about what could be done potentially. We also won a grant from the National Science Foundation to get this started. It was very difficult to win in a normal competition because the security people said this is not security. Then the usability people said you got to talk about security. It was a mess. So we got this grant eventually. And then this year we won a $4.5 million grant from the United States Election Assistance Commission for the Accessible Voting Technology Initiative. And we're going to do demonstration projects and do poll worker training and a lot of things there. And we're going to take Prime 3 and do some unique things with it. And these innovations that we're going to be working on, just to give you some heads up. So the stuff I'm going to tell you now, you're the first people to know about it. So you should feel privileged. So we're redesigning the Prime 3 interface. We're still going to have one contest per screen, but I can show you some samples of this. But what we're going to do is on the left-hand side, we're going to list all the contests so they'll know where they are in the voting process. So it gives an extra navigational aid. And for those of you in HCI, you're familiar with fisheyes, right? Like rollovers. It's a simulated kind of fisheye because the touchscreen, you can't have a fisheye, right? Fisheyes work because the mouse rolls over and it zooms out. You can't do that with a touchscreen. So we're going to have where you touch, and the one you touch on is bigger, and the two next to it is smaller, and things like that. Mail-in voting and signatures in Oregon and Washington State, they do mail-in voting. And if you mail-in vote, you get 3 things in the mail. You get your ballot and 2 envelopes. You vote, you put it in a small envelope, you sign it, and you put it in the big one, and you return it. Then when you receive your ballot, they match your signature, looking at it, and say this is legitimate, and put your ballot in the scanning machine or whatever. Well, we were surprised to discover no one's done any studies to say how good people are at looking at signatures and determining if it's fraudulent. So we're designing a study which I can tell you because I doubt any of you are potential candidates for this study, where we're going to do families. We're going to take a family and ask the people to write their signature and try and write signatures of other family members. And then we're going to have people come in and try and identify signatures and tell me, if looking at two, if one's fraudulent or another. And we're going to use software to analyze signatures as well. So we'll be able to look how good software can do it and how well people can do it. So that's a study we're going to be running soon. Then we came up with this idea of balloting, where if you could use your phone, either call in or have an app, or go online and fill out a ballot, like you saw at Prime 3 or whatever. And then instead of printing your ballot, what if it sent you a QR data code? And then on election day, you show up with your QR data code, which contains what you see there at the bottom, basically your ballot, and you go to the Prime 3 machine, it scans it, and it goes to the summary screen, and you could change it if you want, or you just print it. So our prediction, our hypothesis is that if we enable voting this way, it will make voting faster and more accurate, meaning people will make fewer mistakes if they could practice and then bring in something like this QR data code and then change it. So before anybody says anything, people always say, well, can I buy your vote? Remember, it's just pulling up the summary screen. So you could change your vote. So it's not guaranteed that what you take in is what is actually you put in the ballot box. Then our other project, which is very exciting here at Iowa State, actually, as I discovered, it's called Verify Me. A number of states are requiring voter ID. So there's a debate about this. People say we need voter ID to prevent fraud, and then people say it violates rights, and it's just a big, nasty debate. So we came up with this idea, and we started building this system whereby you would show up at the DMV or somewhere, and then you take a picture using a very good camera. And they take that picture, and you come in and you bring your documents to say you are who you say you are and you live where you're supposed to live. And they say, okay, we register you to vote. Go by. Thank you. Later, you get a letter in the mail saying you're voting at this place. So on election day, you show up and you say, I'm Stephen Gilbert. And then we have a unique interface for this too, which is actually on a tablet. And they pull up Stephen Gilbert, and that picture comes up. So Stephen didn't have to bring any voter ID. His ID is him. Stephen just showed up, and they can look at the picture and then look at his address and say he's okay to vote. So with that in mind, this lecture changed instantly this morning, because I discovered people here at Iowa State are doing some interesting things on high-resolution 3D imaging. So we're looking at doing a study with Iowa State researchers. Can people identify faces more accurately using a 3D image versus a 2D image from a photo? Now that would be cool, right? And Iowa State would love this, because that means every voting precinct registration place would be using your technology to take photos for Verify Me. Wouldn't that be cool? So anyway, let me conclude. So what do we need in voting? Usability is important. It has to be usable by a large demographic of people, varying socioeconomic, education, age, etc. It has to be accessible. The Help America Vote Act requires this by law. You need privacy and verifiability, meaning even after the election, can we go back and audit it, and can I verify my ballot before it's counted? Security. People talk about hacking a system, but the hack only works if it cannot be detected. So we like to say, when we test these, is it the case that you cannot hack the system such that no undetectable change or error can cause an undetectable change or error in the election outcome? That's called software independence. And again, you need an audit trail. And if you can get these things, then I think we have success. Now, the studies we've run thus far suggest that this approach is accessible, is private, is independent. It covers many of these. Security experts have publicly said they support the notion of using optical scan. We've shown some shortcomings in that, and certainly they would support what we're doing in Prime 3 with our voter verified ballot. And I'll stop there and take questions.
You can pass the mic, or Dr. Gilbert can repeat the questions, either of us. We have time for probably one or two. So my question, here comes Anisha.
Thank you for the talk. It was very interesting. I have two questions, though. You have or Prime 3 rather, has a computer-generated voice that sounds like Arnold Schwarzenegger. I want to know, do people have a problem with the sex of the voice? Is it male, female? And what are the possibilities of offering them a choice to sort of choose, what type of voice they would like to hear? My second question pertains to the image versus no image. I'd like to know a little bit about the controversy around that.
Okay. So on the first question, this is just the prototype that you've seen. There's an option where we're going to add settings, and we could allow people to select a male or female voice. Right now, research, when I teach my spoken language systems class, research has said that whether you like it or not, everything has a perception of gender. So in voting, the perception was that it was masculine, and that's why we use the male voice. Don't shoot me, it's not my opinion, but this is what the perception was. So we could test with the female voice. We haven't done that, but that's something we were going to add to it. I mean, we can change the voice. The image versus the no image, people have said they did not want an image because it could sway a person from gender and ethnicity perspectives. It's a nasty debate. We stayed out of it, but the functionality will be in the system. So if people want to use it, it'll be in there. We do know for people with disabilities, the imagery is better. It helps them, in particular those with different mental levels of ability. That helps, but the political aspects of it are winning from the perspective that they didn't want imagery of individuals.
Great. So Dr. Gilbert will be outside in Atrium for a reception for the next half hour. Feel free to ask him further questions, and let's thank him for his talk.
Thank you.